Good morning, girls. How are you? I hope you are all doing fine and okay. Okay, today we are starting our revision sessions, and we are going to be starting with the first lesson that we took after the midterms, which is lesson 15.1, using graphs and properties to solve equations with exponents. In this lesson, we were talking about the exponential relation. The exponential relation. As I told you, the exponential relation is any relation written in the way of ab to the power of x. ab to the power of x. When we said like this, for example, a bracket b to the power of x. This is y equal, for example. So this is called exponential relation. And as we said, a represent the initial value. As we said before, a is your initial. Let me write it in text better. Yes, we said a is your initial value, is the part that you started with. And if you draw, when we draw, it was the value. If you remember, the graph of the exponential relation was like this, for example, and like, for example, growing like this. This will be the value of a. The intersection here will be the value of a. Okay. So a was the initial value. What about b? B was what? B was like the common ratio, or like the, as you are saying, B was like the common ratio, or the number that you are going to multiply with. And in the next lesson, we divided it into either growth rate or decaying rate, if it's less than 1 or it's greater than 1. So here we can write that B was like the common ratio. And if you remember, we had 4 kinds of exponential relation, 4 cases. I hope you remember them. You can graph them very fast, but let me clear. Okay, as I did before, we said that we have 4 cases. Okay, case 1, case 2, case 3, and case 4. Please, girls, take notes of all of this. Okay, let's remember. The first thing was, what will happen if A is greater than 0? It means it was positive, and B was greater than 1. And B is greater than 1, like 1.2, 1.3, 5, 6, 7. It was increasing. So your function, first of all, since A is greater than 0, it's positive, so it's going to be in the positive side, and it's going to be up. So, and since B is greater than 1, the function is going to be increasing, and this was going to be my function, like this. What about this case? This case, for example, was when A is greater than 0, so again it's positive side, but B this time is less than 1. B is exactly 0. B is greater than 0 and less than 1, and B is from 0 to 1, which means it's like a fraction. We said before, B can never be negative, girls. B can never be negative, but it can be either greater than 1 or less than 1, yani from 0 to 1, like 0.2, 0.3, 0.7, 1.2, 1 over 2, 3 over 5. يعني it means it's a fraction. Since a is greater than 0, so it's going to be in the positive side. Since b is from 0 to 1, so it is going to be decreasing function, and this was my shape, decreasing like this. And then for the fourth case, what happens if a is less than 0 and b is greater than 1? Since a is less than 0, so I am talking about the negative side, down. And b is greater than 1, so it's going to be increasing. So it's going to be in this shape. It's getting away from 0. This is the increasing thing. It's getting away from 0. What about the last case, which a is less than 0 and b is greater than 0 but less than 1, and it means it's decreasing, so it's going to be getting nearer to 0, yeah, like this, for example. It's decreasing and it's in the negative side. Those was our 4 cases that we took together. Okay, and then in this lesson we took 4 things. First of all, there was solving exponential equations. We were solving exponential equations. And I told you solving exponential equations can be done in 2 ways, either graphically or algebraically. This was the first part of the lesson that we are going to be solving on. And then the last part was using the graphing calculator to solve some exponents in here, solving a real-world exponential equation by graphing using the graphing calculator, as we are going to be using now. I did for you like a revision sheet. You will be having it. I uploaded it on Class Dojo. Let's open it together and then let's solve it together. It's divided into 3 parts. Question 1, solving by graphing. Question 2, solving by algebraically. And then the graphing calculator thing. Okay, let's start with the first part, which is solving graphically. You have to read the question carefully. Did they tell you graphing or algebraically? You cannot like mix them together, put this in here and this in here. No, you just you have to do whatever he is saying, whatever he is telling you. Let's see how to solve by graphing. Whenever we did graphing before, actually the way will never change. Always you will be having an equation like this. To graph it, you have to divide it into 2 parts. The first part is this, and the second part is this. So actually, as if I have 2 equations. Equation 1 is y equal to 9 power x. Let me do the solution in another color. y equal 9 power x okay 9 to the power of x. This is your first equation. This is your first equation that you have to graph. And what about the second equation? So the first equation that I need to graph is this part. The second equation is y equal to 11. This is the second part of my equation. Okay, I want to remove all of this. Yes, what is this? What is this? Okay. So this is my two equation. The first equation is the first part, y equal to 9 power x. The second equation is the second part, which is y equal to 11. And then I'm going to ask myself, how can I graph the first part? This is a normal equation. This is a normal equation. How can I graph it? Using what? Using a table. Let's take a table and let's graph. So here I'm going to make a table. So for the first equation, y equal to 9x. Let's do a table. The table will be x and y. And as we said before, we can take -1, but actually -1 here will be very far away. Try to look on your graph. Here, 1 is here, so half is here. So -1 should be in the same way in the other side. So it's not here actually. The first number that we have can be -half maybe. So since it's not here, we can start from 0, I think. Yes, you can start from 0 and then work your just like extend it. Yeah, we used to take the points -1, 0, 1, and 2. You take it in this way, but just when I saw my graph here, I saw that 1 is here. So -1 will be in the other side. It will be in here. It's not here. Since it's not in the graph, that's why I removed it, and I will start from 0. So I will have 0, I will have 1, and then I will have 2. And then let's start calculating. Let's put 0 in here. 9 power 0 is 1. So the first thing is 1. And then let's put 1. 9 power 1 is 9. And then let's put 2. 9 power 2. 9 power 2 is like 81. Right? And then let's put the points. 0 and 1. Where is 1? First of all, before you graph, this function is increasing or decreasing? This 9, it's greater than 1 because this is b. The value of b here is 9, right? This is the value of b. The value of a is here. Since there is no number here, so it's 1. A is equal to 1. But b is 9. 9 is greater than 1, so this function will be going up like here. But I have to know. Okay, 0 and 1. Where is 1? This is 12, so this is 2, 2, 4, 6, 8, 10, 12. So this is 2. So 1 will be in the middle. So this is my first point. Exactly in the middle, 0 and 1. And then I have 1 and 9. This is 1. Okay, let's search for 9. We said again 2, 4, 6, 8. So 9 will be in the middle in here. So this is like 9 in here. And then I have 2 and 81. It's very obvious that I will never find 2 and 81. 2 and 81 is very, very up here. 81 will be up. So I cannot find it. So we can graph our function. Like this. So this is my function. Okay. Now let's graph the second equation. The second equation is y equal to 11. The second equation is y equal to 11. Okay, let's search. Where is y equal to 11? Where is y equal to 11? You remember what when we have y equal to a number. This is the graph of what? This is the graph of a horizontal line. يبقى I finished the first equation. I was done. Now I need to graph the second equation. The second equation, y is equal to a number. Y is equal to a number is a horizontal line at this number. I need to graph a horizontal line at 11. Where is 11? As we said, this is 10, this is 12, so 11 will be exactly in the middle. So you will get your ruler. This is graphed by your own hands. For this, grab your ruler. So let's take our ruler and then let's do the graph. So the graph will be my intersection points, مش points, point. So as we said, I graphed the first line, which was the exponential graph, and this was done by hand. And then I did the second equation, which is like a horizontal line. My solution is the intersection point. Where is the intersection point? This is the intersection point. This is your intersection point. So this is my solution. Let's try to find what is the solution. So I'm going to go down, trying to find what is this value. Like in here, what is this value? As we said, this is 1, and 1 is divided into 4 squares. So 1 over 4 is 0.25. So we can say that this is 0.25, 0.5, 0.75, and 1. So this happened before the first point. So we can say like it's like nearly after 1, like maybe 1.1, maybe 1.2, maybe 1.1. So the solution will be nearly x is equal to 1.1. If you do this using your graphing calculator, you will find that x is nearly something like this. Maybe it's not exactly 1.1 since we are doing this by hand. That's why we are saying it's nearly. And it can be 1.1, this is acceptable. 1.2, this is acceptable. But it's okay. Okay, let's do the second equation in the same way. Again, I have two equations. The first equation is 12 power x, and the second equation is 120. But before I do it, I just need to remember one thing. What will happen, for example, let me say that, for example, there was here, before the 12, it was like 4 multiplied 12 power x equal 120, like the question that we did in here. In the first question in your book, just to be clear, in here, yes, 2 to the power of x equal to 96. What did we do? You have to remove the 3 first, as we said. We have to remove the 3 first. Okay? Or even you can graph with it. Okay, let's go back to our solution. Let's do our solution here. Okay. Again, the first equation is 12 to the power of x. So here, I'm going to write that the first equation is y equal to 12 to the power of x. Okay, insert equation e power x, this, and then here I'm going to write 12, and here you are writing an x. So this was my first equation that I need to graph. Okay, and then the second equation is y equal to 120. Yes, and then let's graph. We said, how can I graph the 12 to the power of x? Graph it using a table. So this is what I'm going to do. I'm going to draw a table for myself with x and with y. And then again, 1, and if you start with a -1 as we are used to, -1, 0, 1, 2, -1 here is in the third square, so it should be in the third square here. It's not here. But it's better again to use 0. So let me use 0 and 1 and 2. And then let's start calculating. Before I do anything, y equal to 12 power x, just remember the 4 cases. This is which case? Again, increasing, decreasing, positive side, negative side. What is it? The value of a here, there is no a, so a is 1, which means a is positive. So it's going to be in the positive side, up. 12 is greater than 1. This is the value of b. So it's increasing function. So again, it's going to be increasing in the same way as we did this one. let's put 0. 12 to the power of 0 is 1, so y is 1. And then 12 to the power of 1 is 12, so here it's a 12. And then 12 to the power of 2, it is like 12 multiplied 12, which I think is going to be 144, I think. So here it's a 1, 4, 4. And then let's do our graphing. 0 and 1. Where is 0 and 1? 0 and, yes, 0 and 1. This is 120. Take care. 120 is divided into 1, 2, 3, 4, 5, 6 boxes. So 120 divided 6. So we can say that actually each box is 20. Yeah, this is like 20, 40, 60, 80, 100, 120. So 0 and 1, this is will be like very, very near to 0 in here. So we can say that this is my first point. 0 and 1 is very near to 0. It's like 0. 1 and 12. 1 and 12, you increased a little bit, but still you didn't reach here because again, this is 20. So 1 and 12 is just like in here. Exponential relation depends so much on your, like it's not exactly, approximate. And then 2 and 144. We can go up. This is 120. So this is 120. So this is 120. So the next square is 140. So 144 will be just above it. So we can say that it's like in here. Okay, and then let's do the graph. Of course, your hand on the book or on the sheet or whatever will be much, much steadier than mine. Me, I'm using yani, it will be better for you. Okay, anyway, I finished the first equation. Let's go to the second equation. Y equal to 120. Let's graph y equal to 120. Again, this is going to be a horizontal line at 120. Where is 120? This is 120. So let me do the horizontal line exactly using rulers. The horizontal line will be using rulers. And then where will be my solution? My solution is, let me do the line. Yes, this is better. So this is my two graphs, and then the solution is going to be the intersection point, which is this. Let's try to go down and see what will be the answer. The answer is like in here. It just before 2, so we can say that it's like 1.8. We can say it's like 1.75. So I'm going to write here, as I told you before, since you are doing this using your hand, so an error is, yeah, it's acceptable, the common error. But if you tell me that the solution was 5 point something, this is not acceptable. But you understand that it's a number between 1 and 2, and it's very near to 2, but less than 2. So that's why I'm saying that x is nearly like 1.8, like 1.7, something in this range. Okay, and this was the first part, solving using graphing. Okay, let's go to the second part, which was solving algebraically. Algebraically was much, much, much easier. In solving algebraically, we used the meaning or the definition or the you can use it using the book. It was already written in the book, so we can use the book already. Let's see. In here, you got a rule, yes. When you have b to the power of x equal b to the power of y. As you can see, I have b is my base and x and y are my powers. When your base is equal, your powers is equal as well. When your base is equal, your powers is equal as well. This is the rule that we are using, equality of bases property. And when I tell you that 2 power 2 is equal to 2 power x, then actually x is equal to 2. When you equate the bases, so the powers are going to be equal. Which means what? Okay, let's go back to yes. 5 power x is equal to 625. I need to equate algebraically. I need to equate the bases. 5 power x is already it's a base and a power. Ask yourself, can I change 625 into 5 to the power of something? Can I change 625 into 5 to the power of something? You have to get your calculator and start finding 5 power 2, 5 power 3, 5 power 4, 5 power 5, and so on until you find your solution. But let's try together. In here, girls, actually, if you try, let's try together. 5 power 1 is 5. 5 power 2, 25. 5 power 3, 1 to 5. 5 power 4, exactly 6 to 5. Right? Exactly 6 to 5. So I found my solution. And I can write that 5 to the power of x is equal to the 6 to 5 turned into 5 to the power of 4. It's by trying. I'm trying 5 power 1, power 2, power 3, and so on until I will find the solution. So the bases are equal, 5 and 5. So x is equal to 4. So this is your solution. X will be equal to 4. Okay, let's go to number 2. 4 2 to the power of x equal 1 to 8. There is a small slight difference between number 2 and number 1. In number 1, 5 power x was isolated alone. Was there anything beside it? No, it's 5 power x. Is there anything multiplied it or divided or whatever? No. But in here, I have a 4. So you have to isolate 2 power x first. How to isolate it? I have to get rid of 4. How to get rid of 4? Let's divide by 4 and divide by 4. First of all, I have to isolate the power alone. I have to isolate the power alone. So that's why I divide by 4. What will happen here? 4, cancel 4. And for here, 128 divided by 4, this is going to be like 32. So I found that 2 power x is equal to 32. And now, again, as I told you, I have to change the 32 into 2 to the power of something. 2 to the power of something. Okay, let's try together. 2 power 2, 4. 2 power 3, طبعا you are using your calculator. Or you can do it by your own mind, it's better. 2 power 3, it's 8. 2 power 4, it's like 16. 2 power 5, 2 power 5 is exactly 32, right? So I can say that this is 2 power x equals 2 to the power of 5. So we can say that x is equal to 5 by equating the bases. Okay, okay, very good. Let's go to the second part. Question 3. Again, ask yourself, is the 6 power x isolated alone? It's not isolated alone, right? It's not. So I have to get rid of the 16. But 16 here is down. So I have to get rid, and 16 is like division, since it's not like 4. 4 is multiplied by 2. But here 16 is divided. What's the inverse of division? Multiplication. So instead of dividing, I'm going to multiply with 16 in here. And of course, in here, this is like multiplication by 16. What will happen? 16 will cancel 16. And then let's say, let's see, what is 81 multiply 16? So 81 multiplied 16 is actually 1296. So I discovered that 6 power x is equal to 1296. Now begin trying. 6 to the power of what equal to 1296? Because I have to equate the bases. Let's try. 6 power 1, 6. 6 power 2, 36. 6 power 3, I think 200 something, 256 or something. 6 power 4, exactly 1296. So I discovered that 6 power x will be equal to 6 power 4. 6 power 4 is the same as 1296. So we can say that x is equal to 4. Okay, what about question 4? I have a fraction this time. To get rid of a fraction, you have to get rid of the fraction using multiplication with the reciprocal. And what is the reciprocal of 1 over 12? It's 12 over 1. So this is what we are going to do. Let's multiply here with 12 over 1. And let's multiply here with 12 over 1. What will happen? Cancel, 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 and you are left with 6 to the power of x equal, let's see, 108 multiplied 12. What is the value of 108 multiplied 12? 108 multiplied 12 is the same, it's 1296. So actually they became the same question. So we can, sorry, this is not x, this is 6129, not x1296. Okay, so actually again x is going to be equal to 4. It turned out to be the same question. Okay, what about question 5? It's isolated already. Nothing is multiplied with it. So I don't need to divide or multiply anything. I just need to ask myself, how can I turn 4 over 5 power x? Or how can I turn 64 over 1 to 5 to be the same as 4 over 5 power x? Okay, girl, when you have a fraction like this, just think of any number. You don't need to think of the two numbers. Just ask yourself, can 64 be 4 to the power of something? Can 1 to 5 be 5 to the power of something? This is the question. So actually it's going to be what? 64 is actually 4 to the power of 3, right? It's actually 4 to the power of 3. And we can say that 4 over 5 to the power of x is actually, if I try on the calculator, 64, 4 power 1 is 4, 4 power 2 is 16. I think 4 power 3 is 64. 4 multiply 4 multiply 4, it's exactly 64. Yes, it's exactly 64. So we can say that 64 over 1 to 5 is actually 4 over 5 to the power of 3, which means that x will be equal to a 3. Did you see? And do not confuse yourself with the 4 over 5 and tell me, teacher, I'm going to change it into fraction, or teacher, I'm going to change it into decimal. No, nothing. Just think of the as if it was 4. It's not 4 over 5. Ask yourself, 4 became 64. How? And then begin trying. I tried until I found 4 power 3. So it's going to be actually for both. And let's see, 5 power 3 is actually 1 to 5. So you are on the good track. So when you have a fraction like this, just think either above or below. Do not think with the fraction as a whole to be confused. Okay. We still have question 6 in here. Okay, let's do it. Here you have, okay, since I have a fraction, to get rid of the fraction, as we said, I have to multiply with the reciprocal. So this is what I'm going to do. What is the reciprocal of 2 over 3? It's 3 over 2. So multiply with the 3 over 2 in here and the same in here. Cancel, 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 and cancel. And then I'm left with half power x is equal to, let's see, what will be the answer here? The answer here, I think, is going to be like 3 will go with the 6. So I think it's going to be 1 over 4. Yes, the answer is going to be 1 over 4. And then 1 became a 1 because 1 power anything is 1. 2 became a 4. 2 power what equal 4? 2 power 2. So I can say that actually this is equal to 1 over 2 to the power of 2, which mean by equating the bases that x is equal to 2. And this was the second part of the lesson, which was solving algebraically. Solving algebraically. Okay, the third and the final part of this lesson was solving using graphing calculator. And round your answer to the nearest tens. Okay, in here you were required to read a certain problem and then formulate an equation for it. And then instead of solving using graphing, which we did in the first part of the lesson, in which you will put two equations and then make a table and then draw a horizontal line and find the solution, everything is going to be done using the graphing calculator. And already I showed you how to do it before, but I'm going to do it again with you in the revision, and I'm going to assign the graphing calculator for you to do to practice on it. Okay, let's read the question. A town with a population of 600, a town with a population of 600 is expected to grow. What is the 600? Didn't we say before? You remember in the second lesson, which we are using in here actually, we have two kinds of exponential equation: the growth equation, or the growth model, or the decaying model. You remember? Because actually we are using this in here. If you remember, I told you y will be equal to a1 plus r to the power of t. And there isn't a t here, I'm going to put it now, or the decaying model, which is y equal to a1 minus r to the power of t. Here, there is a power of t small here, and here as well. If you read the word increase or the word grow or these words, it means you are using the first model, the first part. If you hear the word, if you hear or read the word decrease, decay, so you are using the second model. What were those? A was your initial value. A was your initial value. R was what? R is your growth rate. And when he tell you it's growing by 8%, it's increasing by 9%, whatever, the annual rate, those things are R. Okay, and 40, it's the time after 9 years, after 10 years, after whatever years. Okay, so let's read the question. A town with a population of 600. So 600 is the what? Is A. This is your initial value. Is expected to grow at an annual rate. This is what? This is R, right? So I'm extracting information. A is 600. A is equal to 600. My R is 5%, and I don't deal with percent. So to get rid of the percent, I'm just going to divide by 100. So 5 by 100 equal to 0.05. So we found our R. Is expected to grow. Grow, it means I'm using which model? I'm using the first model. It's a growing model. So Y is going to be A, which is 600, multiply 1 plus 0.05. Actually, 1 plus 0.05, I mean 1 plus R. Yeah, it means 1.05 right away. Power T. Because he didn't tell. Did he tell you after how many years? He didn't tell you. This is my unknown, the t. Okay. Write an equation. We wrote an equation. And find the number of years. Find the number of years. So this is my unknown. It's expected to take the time to reach the population of 900. Yani he wants this equation to be equal to 900. Right? Or we can say, in other words, we can say that if this is my y1, this is my first equation, the second equation will be 900. Yani actually the equation was 900 is equal to 600 multiply 1.05 to the power of t. And then to solve this using the graphing calculator, I have to divide it into two equations. This was the first part, this part including the exponential, and the second part is y2 equal to 900. And then what should we do? I should go to the graphing calculator and graph it. So let's go to the graphing calculator. Okay, the first equation was 600 multiply. You have to put multiply in here because he doesn't understand what is the putting the bracket right away. No, it's multiply, and then I will put a bracket 1, use this bracket 1 here, 1.05, close the bracket, to the power of x. There is no t here, so I named it x. Okay, and for the second function, it is 900, right? Okay, actually, if you try to graph this right away on the graphing calculator, it's our graphing calculator span is very little. You will not find the solution. So it's better to like make it simpler. Let's simplify it. 900 and 600. What do you think? Can we make it simple? Yeah, actually we can, right? Can I divide this by 100 and this by 100? We can do this to make it easier. So let's divide here by 100 and let's divide here by 100. I'm just make it easy for myself so that I can graph. What will happen here? This 900 over 100 will become a 9 equal 600 by 100 will become a 6 multiply 1.05 to the power of x. What did I do? I just removed the zeros. I divided by 100 here and there so that it will become easier. Anything you do in the left hand side, you have to do it on the right hand side. So now this is my equation. It will be much easier to graph it now. So let's go back to our graphing calculator. Instead of the 600 thing, did you see when I graph? I didn't find actually the solution. The span is little. So that's why I decreased it. So this became 6 and this became a 9. And now we can graph and we can find our solution right away. What do you think? Where is the solution? Even you decrease, this is my red function, the exponential, and then y equal to 9. This is the y equal to a 9. So here y equal to a 9. So if you increase, my solution is in here. To find this, I'm going to just like trace this point. My intersection point is like maybe it's between 8 and 9. We can say like it's 8.5. So the solution is 8.5. So we can say that approximately after how many? Approximately the solution will be like x equal to 8.5 years. So after nearly 8.5 years, the population of this town will reach 900. Did you understand? Okay, let's do another question. This will be our last question for this day. Okay, Mike has a savings account with the bank. The bank pays him annual interest. Interest, girls, means growing. This is interest, and something added on your savings. So this is a growing rate of 1.5. So this 1.5, I understand that this 1.5 is R. This is R. He has $4,000. This is what? This is the first value we started with, so this is A. And wonders how much he will have in the account in 5 years. He wants to know after 5 years he will take how much. Write an exponential function to model the situation and then find how much he will have. Okay, actually this is much easier because you already know that after 5 years he will be having this much money. So let's say my exponential is a 1 plus r to the power of t. So 4,000 y equal, of course, 4,000 multiply 1. We didn't change r first. Let's change it first. R is equal to 1.5% divide by 100. It's going to be like 0.015. 0.015. So here it's going to be like 1.015. And 1 plus r to the power of, this time he already told me it's to the power of 5. It's to the power of 5. So actually I don't need a calculator in here. You don't need a graphing calculator, I mean here. He is asking about the value of y. So what you're going to do is just put this on your calculator and find the answer. So 4,000 multiply 1.015 to the power of 5 and then get your answer right away. And then get your answer right away. So using our calculator, I think the answer here will be nearly like 4309 point something, 4309. Right? Okay, I'm going to give you just an extra question just to practice on the graphing calculator thing. Okay, the last question to do today. How long will it take a 20,000 earnings 3.5 annual interest to double? It is the same as the first question. Okay, the first value here is A. 3.5%, this is my R. And the annual interest, so again, it's increasing. To double means, what is the double of 20,000? 40,000. To double means it became a 40,000. So let's write the equation. Y equal A, which is 20,000, multiply, we are going to turn R. R is going to be 3.5 over 100, so 0.035. So 1.035 power t. And this is equal to what? This is equal to 40,000 because it's going to double. So as I did in the first question, to make it simpler, 20,000 and 40,000, how can I get rid of this? To make it simpler for myself. Let's divide here by 20,000 and let's divide here by 20,000. Yani if I divided here with a 20,000 and divide here with a 20,000, so can I make it easier? Can I remove 20,000? Yes. Let's divide here with a 20,000. because both of them are divisible by 20,000 here and there. So what will happen is that 20 will cancel 20, and in here the answer will be 2. So 2 is equal to 1.035 to the power of t. So of course I make it much easier for myself. Now I can go and graph. This is my first equation and this is my second equation. Let's go to the graphing calculator. So the first equation is 1.035 to the power of x, and the second equation is 2. And then let's graph. We need to move to find the solution. Yes, the solution is in here. Okay, to find it, let's do trace. Okay, so my solution, my intersection point can be actually in here. So maybe it's 20. Yes, maybe it's 20. So we can say it's like nearly after 20 years. It's like nearly after 20 years. So how long will it take for the earnings to double? After 20 years. So this is what you are going to be writing here. How long will it take after 20 years? Okay, so this I did using the graphing calculator. Okay, so lesson 15.1 is done. For tomorrow, try to prepare lesson 15.2. And if you have any question, please, you have to study this today, so that if you have any question, just ask me on Class Dojo or in our online lesson, inshallah, on Tuesday. Okay, thank you and goodbye.